start recording to the cloud, sharing the screen. And oh my heavens, I sound like an old lady. I'm pontificating to you guys about student government and COVID vaccines and all sorts of not math related things. And of course, you'd much rather hear about math. Today, we're going to finish looking at parabolas. It'll actually be the end of this unit. I am looking at exam 3, and we were talking about having it due next Thursday, but now by the end of the day. But now I'm thinking that that day is the day that we won't have class, which will free up a 2-hour period for you guys to take that exam. Is that sufficient? Or do you guys want me to make that exam due instead, maybe Friday or Saturday, so you have some weekend time to work on it? I would prefer it if the latest it was Saturday night, so that I could grade them on Sunday. Does anybody have a preference in terms of exam taking time? If we don't have class that day, does that free up enough time for you folks that you would normally be in class, or do you guys need like weekend time for it? Or don't you care?
Yeah, it really doesn't matter to me.
Okay. All right, well then, let's regroup and talk about it on Tuesday. On Tuesday, what we'll be doing is reviewing for that exam, answering whatever questions you have left over on any of the homework, and also going over a practice exam so that you know what to prepare for. Homework due dates are listed here. This one that was due on the 30th. I know that my labs has been misbehaving. I've gotten lots of emails from my coworkers, the other teachers in the math department, saying that their students have had problems. They've reached out to Pearson, and Pearson said that it is indeed a Pearson-wide problem. I think I sent a link that I got from one of my coworkers, Mr. Miller in the math department, as an alternate way to get into my labs if the Blackboard link is not working. Does anybody, if I was going to say, do you guys want me to push that due date back? But instead I'm going to say, if you had problems and you couldn't get that done because of Pearson problems, when you finish it, send me an email and I'll take away the late penalty. In terms of these assignments, has anybody started looking at any of them? Does anybody have questions on any of them? Does anybody want me to open up the homework and look at any problems?
I had like on 2-4, 2.4, number 11.
Okay. Let's see. And actually, I have to apologize as you are saying that. Hopefully this question deals with it, because I did get an email question from somebody last night and realized that there was one phraseology that we did not discuss in class, and I have to apologize for that. Let's hope that your question deals with that. Okay, Pearson's not real fast, but it's not as slow as it has been the last couple days, so hopefully we'll get through here. Question number 11. Okay. This one asks you to find the slope-intercept equation of the function that passes through the given, fits the given situation. And so it says that we want something that passes through this point and that it's perpendicular to a line. When I see that word perpendicular, I immediately know that I have to look at the slope. And so those combinations tell me that I'm going to be using the point slope formula. And so what we have to do is we have to see the slope of this line here. Now this line, if that's the x-intercept, that tells me if the x-intercept is 2, that it goes to the point 2, 0. And likewise over here, if the y-intercept is -6, doesn't that tell me that I go through the point 0, -6? And so while we don't know the slope of this line, we've got the information that we can use to find it. And so the slope is the difference in the y's over the difference in the x's, which would give me -6 minus 0 over 0 minus 2, which gives me -6 over -2. So that line has a slope of 3. If that line has a slope of 3, the perpendicular line is going to have the slope that's the negative reciprocal of that, which would be -1/3. Now we're going to use the point slope formula, which is y minus the y value of the point is equal to the slope times x minus the x value of the point, giving me y minus 4 is equal to -1/3 times x minus -6 would be x plus 6. It doesn't say what form to put it in. It asks for a function, so let's go ahead and solve for y. It'll give me y minus 4 equals -1/3 x minus 2. And adding 4 to both sides, I'd have y equals -1/3 x plus 2. I don't know if they want y equals or f of x equals. If they don't accept y equals, type it in as f of x equals. So I'm guessing that what might have made that one problematic was realizing that here, when I was given both the intercepts, I was given the information, I was given the coordinates of 2 points that I could use to find the slope. Is that one better?
Yes, thank you.
You're welcome. Any other questions? If not, I'm just going to go back for a minute and double check my email to see the one that the student in the other section asked me about last night. And I have to apologize, my Chromebook went to sleep, so it's going to take me a minute to get in there. Okay, it was 2.4, question number 8. So let's see, we're in 2.4. I'm going to erase this and backtrack to question number 8. Nine does the same thing. So we're stopped on 9. Let's use 9. The question asks us to find the average rate of change. And I have to apologize. We didn't use that phraseology, average rate of change. What you need to know is that the average rate of change is actually very much like the slope. It's the difference in the y values over the difference in the x values. When we look for the average rate of change of a function that's not a line, well, since it's not a line, we don't call it the slope. We call it the average rate of change, but it's that same idea. And so if we're looking for the average rate of change of this function, which is f of x equals the square root of x, well, if x1 is 9, f of 9, I apologize, this pen is not writing very smoothly, would be the square root of 9, which is 3. So that means that my 1 point is 9/3. And then if x2 is 49, f of 49 is the square root of 49, which is 7. So my second point is 49, 7. Now for the average rate of change, I'm just going to plug those into the slope formula. So I'll get 7 minus 3 over 49 minus 9, which gives me 4 over 40. And so the average rate of change is 1/10. And I apologize that we had not used that phraseology, average rate of change, in class. That one, okay. Were you guys all right with that one anyways, or did that average rate of change cause issues? I apologize if it did.
No, that's okay. That helped. Thank you.
All right. Now I'm going to clear this. Does anybody want to look at any other homework questions from any of the assignments before we carry on with our discussion of parabolas? Have I waited long enough, or are there any questions that remain? All right, not hearing any questions. Let me turn my finger back into a mouse, back out of here, and look at the notes for the day. So to this point, what we've done is we've said that a quadratic function is a function of the form f of x equals ax squared plus bx plus c, and that would be my general form. And then we took that general idea of transformations and said that the vertex form of a quadratic function is f of x equals a times x minus h quantity squared plus k. And we said, well, that means that we're looking at the idea of transformations that we spent a bit of time discussing last class. We were going to take a general y equals x squared, move it h to the right and up k, which would take the vertex from the origin to the point hk. And then we would do a stretch of a. And we said that if a is positive, our function is happy, it opens upward, which tells us that our turning point is a minimum. And we said that if a is negative, that means that our function is a little bit on the grumpy side, it opens downward, which makes our turning point a maximum of vertex. We said when we graph these, we use an axis of symmetry because they are very symmetric graphs. You should be able to fold it over a line. And that line that we fold it through is a vertical line that goes through the vertex. So it's that line x equals h. And we said otherwise to graph, the other points of note are going to be the intercepts. And for the x-intercept, to find it, we substitute y equals 0. And to find the y-intercept, we substitute x equals 0. And I think that was what we had developed the second half of class on Tuesday, but we only had the opportunity to look at one example. Everybody back in that place where we left off Tuesday? If so, let's look at a second example. Let's go through and let's sketch the graph of g of x equals x plus 3 quantity squared plus 1. In finding it, things we want to find are the vertex, axis of symmetry, whether it has a maximum or a minimum, the intercepts. And I do believe these questions also ask you to find the domain and range in interval form. I think that's all we need. And so, is it clear that this is in vertex form and not in intercept form? I'm sorry, not in general form. So, you know what? Yeah, we'll just leave it as it is. If I compare that to g of x equals a times x minus h squared plus k, first thing we want is a vertex, which is our point hk. And so h is what we're subtracting from x. That would be -3. K is what we're adding at the back. So k is 1. So when I make my sketch, I know my turning point is the point -3, 1. If my turning point is the point -3, 1, the axis of symmetry is a vertical line that goes through that point. And so my axis of symmetry is the line x equals -3. To determine whether it's a max or a minimum, I look at A. And so, oh dear, when I scrolled up, I lost the equation. Let me scroll back down a little bit. What's A? What's the coefficient on those parentheses if there's nothing written?
One.
Beautiful. And if A is 1, that's positive. And so we're going to be opening upward. Excuse me. And if I'm opening
God
upward,
bless you.
yeah. Hey, is there anybody else who, like, with the change of seasons, all of a sudden your head is like, I've heard, I heard something weekend and Friday that somehow this year, whatever gives people seasonal allergies seems to be worse. But I also heard something on the radio yesterday that said wearing a mask should help people with seasonal allergies because some of those stuff that messes with your head doesn't penetrate the mask. But I digress. I apologize for sneezing in your ears. So if this is opening upward, does everybody see that that turning point would be the lowest point? So we'll have a minimum. And that minimum value would be my 1. Now, to finish our graph, we want to find our intercepts. And so first, let's find the y-intercept. And if I substitute 0 for x, g of 0 would be, I lost the equation again, 0 plus 3 squared plus 1, which would be 9 plus 1 or 10. And I'm crossing my y-axis at 10. And again, because of that symmetry, I can get another point same distance away on the other side. For the x-intercept, we want where y or g of x equals 0, which gives me 0 equals x plus 3 squared plus 1. I would, again, when I'm in this form, I'd use that square root method of solving. So when I subtract 1 from both sides, I get negative 1 equals x plus 3 squared. And then I'll use that square root property, which gives me x plus 3 equals plus or minus I. Wait a minute. I is not real. So this tells me that I have no x-intercept. But now I want to go back to the information that we have on the graph already and notice that we probably could have reached that conclusion without going through all of that work. Because if this is the lowest point, and my graph is going upward through those other two, through those other 2 points, is it obvious from this if it's going up? It will not be crossing the x-axis. So if my turning point is above the x-axis and it's opening upward, I don't have to worry about intercepts. Conversely, if my turning point was below the x-axis and it was opening downward, I also would not need to worry about those intercepts. Now, for the domain, do you remember at the beginning of this unit when we were looking at graphs to find the domain and range, we were looking at things like this. We said the domain was how far left, how far right does it go? We notice that this is a continuous graph. We don't have to lift our pen to graph it, so we're not going to have any missing values. It'll be everything from the furthest to the left to the furthest to the right. And we notice that because it has those arrowheads, it keeps going in either direction. And so here the domain will be from negative infinity to infinity, or all real numbers. The other way we could get that idea that the domain is always all real numbers for a quadratic function is, I'm going to go back to the first page. We had said that these quadratic functions are something of the form f of x equals ax squared plus bx plus c. And remember we had said the domain will be all real numbers for which it is defined. There's no radicals here, so we don't have to worry about that. Also, there's no fractions here, so we don't have to worry about that. And so because this is just a polynomial, there's no place where it's undefined. So in general, for a quadratic function, your domain will be all real numbers. But now going back, I guess I'm going to leave a space to the idea of the range. For the range, we can get it by looking at our graph. This does have a bottom. That bottom value is 1, and it goes up from there. And so the range would be closed at 1 and then go on to infinity. We can get this again by looking at the graph. But we can also get this from the idea that we have that minimum value of 1. If 1 is the smallest value and it's opening upward, that would also give me the idea that 1 is the smallest value in my range. And I apologize, that shouldn't be negative infinity, that should just be infinity. I miswrote. If we're going upward from there, we do not have a maximum value. So let's look at one more. Let's look at, let's sketch. Find the vertex, the axis of symmetry, whether it has a max or min, the intercepts, the domain and range, and this time let's have f of x equals, let's make it -2 times x plus 1 squared plus 8. Oh, you know what? I apologize. I'm going to change that a little bit. Let's turn that 8. Just leave it. Okay. I'm going to be quiet. And I'm going to ask you folks to find the information about this one. Give you folks a chance to try. How are you guys doing? Do you need more time or do you want to go over?
We can go over.
Okay, so our function was f of x equals negative 2 times x plus 1 squared plus 8. If I compare it to f of x equals a times x minus h squared plus k, hopefully everybody noticed that a is negative 2, h is negative 1, k is 8. I'm going to make that a little bit bigger so it's easier for you to read. And so my vertex hk is negative 1, 8. Negative 1, 8. My axis of symmetry is a vertical line through that. Vertical lines are always of the form x equals. And so I get x equals negative 1. Because a is negative, it tells me that that's opening downward. Then to finish the graph, my y-intercept, when x is 0, f of 0 is negative 2 times 0 plus 1 quantity squared plus 8. Remember your order of operations, this would be 1 squared is 1 times negative 2 is negative 2 plus 8 is 6. So I cross the y-axis at 6. And again, because of that symmetry, if I'm going 1 over to the right, I'll have the mirror image point to the left. And then to have the x-intercepts, I substitute in 0 for y or 0 for f of x, which gives me 0 equals negative 2 times in parentheses x plus 1 quantity squared plus 8. Because it's in that form, rather than working it all the way out to solve the quadratic, it's easiest to use the square root property. So let's subtract 8 from both sides. Divide both sides by negative 2. When I take the square root of both sides, I get 2 equals x plus 1, or negative 2 equals x plus 1, because again, remember when I take the square root, that 4 has 2 roots, a positive and a negative. Solving the first gives me x equals 1. Solving the second gives me x equals negative 3. And with those points, I'll finish my graph. Again, because it is a quadratic function, because it is a polynomial function, because I don't have to worry about any values to exclude, the domain will be from negative infinity to infinity, all real numbers. Or again, by looking at the graph, I can get that because those arrowheads going right and left. Because those arrowheads are going down, I know there's no minimum value. So my range will be from negative infinity to that turning point. That maximum is 8. How do we do? Any questions? Did everybody get that? If there are no concerns, that is probably the easiest approach to graphing a quadratic if it's in this vertex form. Issues arise, though, if I want to sketch a quadratic in general form. Which is that f of x equals ax squared plus bx plus c. Here, we have a couple options. If you really enjoy completing the square, we could gently massage our equation to get it into the vertex form. But most people are not a big fan of that. And so when we looked at coming up with the quadratic formula, we looked a little bit at what was involved in completing the square with this general one. Do you guys mind if I skip the derivation with this one and just say that in general to sketch? Again, we're going to look at A. A is going to give us the direction, just like before. If A is positive, we're opening upward, which means that that vertex is a minimum. And if A is negative, we're opening downward, which means that that turning point is a maximum. And then what's a little bit different with these, I've always found it easiest to next find the axis of symmetry. Here, if I factored the A out and completed the square in X, I would get that constant K, that axis of symmetry, will be the line X equals negative B over 2A. And then once I find that negative B over 2A, to find the vertex, we know that the X value is that negative B over 2A. To find the Y value, Y would be F of whatever that quantity is, F of negative B over 2A, which looks a lot uglier than it is in practice, because that negative B over 2A won't be an algebraic expression, it will be a number. Then after that, we'll find the intercepts. And again, the intercepts, the y-intercept is going to be when x equals 0. So the y-intercept will be f of 0. And the x-intercept occurs when y equals 0, which would be the solutions to 0 equals ax squared plus bx plus c. And again, last unit we spent quite a bit of time solving those quadratic equations. And so hopefully that's something that isn't too much of a challenge for anybody to find. So then there are the rules. Let's go through and try a couple examples. Up, did I turn the page too fast? Does everybody have all of that down, or do you need for me to wait a minute? We all good?
Yeah, I'm all good.
Great. So let's, for an example, let's sketch f of x equals x squared minus 2x minus 6. Let's find the axis of symmetry. Let's find the vertex. Let's determine if it has a max or a min. Let's find the intercepts. And let's find the domain and the range. Not too tall in all order. Okay. So this again is not in vertex form. Again, we could complete the square and put it in vertex form. But being that it's not in vertex form, let's compare it to the general form f of x equals ax squared plus bx plus c. And doing that comparison, A, B, and C turn out to be exactly like what they were when we were looking at solving a quadratic equation. A is the coefficient on x squared, which is 1. B is the coefficient on my first degree term, the coefficient on X, which is -2, and C is -6. So my axis of symmetry is given by X equals -B over 2A, which substituting would be the negative of B is -2 over 2 times A is 1, which gives me 2 over 2 or 1. So my axis is the line X equals 1. And my vertex is on that line. And since it's on that line, my vertex would be the function value when X equals 1. So f of -B over 2A, here would be f of 1. We're taking that value and substituting it into the function. Would be 1 squared minus 2 times 1 minus 6, which would be, what is that? 1 minus 2 minus 6 would be -7. And so my vertex is the point 1, -7. To determine if I have a max or a min, I just look at A. A is 1, which is positive, which means I'm opening upward. And so I have a minimum. And the minimum would be that -7. That would be the lowest value that this function has. Before we go too much further, let's put this information on a graph. My minimum, my vertex is 1, -7. My axis is the line X equals 1, and I'm opening up from there. For my y-intercept, again, I substitute in 0 for X. And so f of 0, when X is 0, I get 0 squared minus 2 times 0 minus 6, or -6. So my y-intercept is -6. I'll cross that y-axis at -6. And again, if that point is on the graph, due to that line of symmetry, I'll have another point equidistant away. Then for the x-intercept, if I look at y equals 0, I'm solving 0 equals x squared minus 2x minus 6. In order to solve that, we have a couple of choices. Do you see the glass is half empty or half full? We can factor. We can complete the square. Or we can use a quadratic formula. But I'm looking at this one, and actually, I don't think this one is factorable. So let's use a quadratic formula. X equals -b plus minus the root of b squared minus 4ac all over 2a, which would give me the negative of -2 plus minus the root of -2 squared minus 4 times 1 times -6 over 2 times 1, which gives me 2 plus minus the root of, let's see, that would be 4 plus 24 or 28 over 2, which would give me 2 plus minus, let's see, 28 is 4 times 7. So that's 2 square roots of 7 all over 2, or 1 plus or minus the square root of 7. And so in terms of exact value, that's what we would have. In terms of graphing it, I'm going to take my calculator and estimate 1 plus the square root of 7 is approximately 3.6, and 1 minus the square root of 7 is approximately negative 1.6. And so halfway between, a little bit more than halfway between 3 and 4. And a little bit more than halfway between negative 1 and negative 2. And there's my graph. When you graph these in my labs, you're going to be using a graphing tool. And so let me real quick pull up my labs and look at quadratic functions. And I apologize. Pearson is slow, as is my internet. This one's not asking us to graph it, so let's move a little bit further in the assignment. Look for one that does ask us to graph it. Yeah, okay, there you go. And so in order to graph this, my, well, I'm going to use this tool. I'm graphing a parabola that is a function. So you'll always use this version of the parabola and not the one that opens horizontally. That's not a function. My vertex would be -2, -1. So I'm going to hit that point. And then from there, real quick, let's say the y-intercept would be 3. And so I'm going to just go to that point. And you notice that with this graphing tool, while graphing by hand, we need more than 2 points, but with this graphing tool, you only need those 2 points. All right. And so that's how you're going to be graphing these in my labs, as opposed to when we graph them by hand, we usually need more than just 2 points. Okay. So let's go back here. Any questions on this process? If not, I'm going to ask you folks to please sketch f of x equals -5x squared plus 5x. I want the direction, the axis of symmetry, the vertex, and the intercepts. Oh, and I apologize. I'm going to go back for a minute. We found everything for this one, but I apologize. We didn't find the domain and the range. So let's double back and do that. The domain, because it's a quadratic function, because it has arrows right and left, will be from negative infinity to infinity. All real numbers. The range, because this open upward, it has a minimum value. And so that smallest value that it equals is -7. And because it opens upward, it doesn't have a maximum value. So the range will be from -7 to infinity. Everybody okay with that? And I apologize that I missed that. So let's find the intercepts and let's find the domain and the range. And this time I'm going to be quiet for a couple minutes and ask you to please go through and find those quantities. How are you folks doing? Do you want me to wait a minute or are you ready to go over? Should we keep waiting or are you ready?
I'm ready.
Yeah, I'm
So
ready to go over too.
f of x equals negative 5x squared plus 5x. If I compare that to ax squared plus bx plus c, does everybody see that a is negative 5, b is 5, and c is 0? Those are actually the decisions I'll write for everybody.
Yep.
Since a is negative, you know that this thing opens downward. Axis of symmetry is negative b over 2a. So that's the negative of b is 5 over a is negative 5. So that's negative 5 over 2 times negative 5, which would equal a half. So for my vertex, that's the value that I put in for x, because my axis is that line x equals a half. And so f of a half would be negative 5 times a half squared plus 5 times a half. A half squared is a fourth. So that's negative 5 fourths plus 5 halves. And when you do the arithmetic, that gives you positive 5 fourths. And so my vertex is the point. It's not negative a half. I apologize. I don't know why I wrote that minus sign in there. Is a half 5 fourths. For my y-intercept, I substitute in x equals 0. F of 0 is negative 5 times 0 squared plus 5 times 0 is 0. So I cross my y-axis at 0. For my x-intercept, I use y equals 0 or f of x equals 0. So this becomes 0. And I've got 0 equals negative 5x squared plus 5x. That one I solved by factoring, and I got x equals 0, x equals 1. Now this part here, x equals 0, that makes sense, because if I cross my y-axis at 0, that means I'm going through the origin. And so I'm also crossing my x-axis at 0. I'm crossing my x-axis at 1. In order to graph fractions, and I think that in my labs, they do the same. In order to graph fraction, if you look at the way the axis is scaled on my graph paper, the whole numbers would be 2 blocks away. And so this middle block would be a half. And I could put in my x equals a half. At which point I have to apologize. All of a sudden, my stylus does not want to work for me. Give me a second. I hate it when it happens. Do you guys ever have some sort of piece of electronics that all of a sudden it doesn't want to work for you, and to get it to work, you need to like pull the battery out and rub it on your pants or a piece of fabric, and then keep your fingers and toes crossed and hope that it works again? Isn't that crazy? And so I've got this line, x equals a half. And again, if 2 blocks are 1, a quarter would be halfway in between. So that's my turning point, and I open downward from there. Again, because it's a quadratic function, the domain would be all real numbers from negative infinity to infinity. Because my turning point is a maximum, my highest value in the range is 5 fourths, and since it's opening downward, they'll go from negative infinity to 5 fourths. Is this all right? Any questions? Did you want to try another one? Or are you feeling confident here? Nobody's answering. And so I am going to pull out this great big textbook and look for interesting example. Let's have you folks graph f of x equals let's look at 2x squared minus 8x plus 3. I want the axis of symmetry, the vertex, the direction, the intercepts, and the domain and range. And I'll give you a couple minutes. How are you folks doing? Do you need time or do you have it? Should we go over or wait?
Can I get a moment, please?
Yes, that's why I'm asking. I want to make sure we're doing it right. Thank you for speaking up. I appreciate that. You don't know how much I love it when you guys actually talk to me. Oh dear. I'm just realizing something. I forgot to be mean to you. I totally forgot that it was April Fool's Day. And I was going to act like today was the test and you were supposed to be all ready and take it during class time. Oh, well, April Fools. Have any of you done any good April Fool's pranks?
No, my brother did this morning though. He was like, "Listen, time to get up for school," and I was so tired. I'm like, "Al, it's not school time." And he's like, "April Fool." I'm like, "Oh my god, I didn't realize it was April Fool's Day." It's bad.
Usually on campus, for April Fool's Day, which I guess is me, and I start passing out blank papers and make people think that it's a pop quiz. And then I go April.
Oh no, that's not good.
So, oh well. Let me know when you guys are ready.
I'm ready now.
Okay. So, looking at it, did everybody get, first of all, that A is 2, B is -8, and C is 3? So for the axis of symmetry, when I look at -B over 2A, I get the negative of -8 over 2 times 2, which gives me 8 over 4 or 2. So the axis of symmetry is the line x equals 2. Once we've got that, we take that value and plug it into the function to find the corresponding y value for the vertex. So f of 2 gives me -5. And so my vertex is the point 2, -5. Then in terms of a direction, I just look at A. Here, because A is positive, this is opening upward. Since it's opening upward, that tells me I didn't write it. But since it's opening upward, that vertex, that, this is not liking me. -2 is the minimum, the lower point. For the y-intercept, when I find f of 0, putting 0 in for x, I get 3. So I know that this goes through the point 2, -5. It crosses the y-axis at 3. Again, with my labs, that would be sufficient to draw your graph. To find the x-intercepts, we've got to solve where does that equal 0. Again, this one needed the quadratic formula. And so doing that, when I have 8 plus or minus 2 radical 5 over 4, I can factor out a 2, which gives me 4 plus radical 5 over 2 and 4 minus radical 5 over 2, which I think with my calculator was a little bit less than 1 and a little bit more than 3, which corresponds with that graph that I got. Because it's quadratic, the domain is all real numbers from -infinity to infinity. Because it's opening upward, that vertex, that y value of the vertex is my minimum. That's my lowest y value. And so from there, I'll just keep on going. All right. Then Last thing we're going to look at are some application problems. And I have to apologize, I forgot to upload application problems to the notes. So I'm gonna real quick snag a couple from the homework. What I'll do is I'll take a screenshot of them and upload them into the notes for you. Applications with these, we're looking for word problems. And most often they're word problems that ask for a maximum or a minimum value. And so I'm going to go back into that homework and I'm going to scooch down to, if it lets me. Okay. No, this isn't the homework that I wanted. Yes, it is. I'm going to scooch down to, why is it telling me it's late? This one's not due yet. The last question. And let me just real quick take a screenshot of that. And paste that into the notes. Yay, it worked. Every once in a while, I'm so afraid that the technology and I are not going to be friends, but sometimes it works. So here we go. It says the rain gutter is made from a sheet of aluminum that are 14 inches wide by turning up the edges to form right angles. So picture this, that over here on the right, we have a piece of sheet metal that going all the way across is 14 inches. In order to turn it into a gutter, we're going to figure out some distance on either side and bend it up to get this rectangular shape. We want to determine the depth of the gutter that will maximize its cross-sectional area and allow the greatest amount of water to flow. So the depth of the gutter, we're talking about this dimension here, and they've gone through and they've labeled that for us as X. And so if this dimension here is X on one side, it's X on the other side. And so if the whole sheet of metal is 14 inches across, does it make sense that if I fold up X on either side, that middle piece will be 14 minus 2X? Everybody follow the reasoning to that. Now, when they ask for that cross-sectional area, the cross-section would be this rectangle. And so what we're looking for is the area of the rectangle. And hopefully everybody remembers that the area of a rectangle is length times width. And so that would give me one dimension is 14 times 2X, and the other dimension is X. And so I guess let's call that A of X. It'll be a function of X, and I'll call it A for area. Why the hell not? So that gives me A of X distributing equals 14X minus 2X squared. Or if I want to put it into a more standard form, it would be negative 2X squared plus 14X. To that point, is everybody all right? Can everybody kind of follow through the reasoning of why that is 14 minus 2X and how that expression that I just wrote gives me the area of that cross section which is a rectangle.
Yeah, that makes sense, right? The equation is written like that.
Now, as I look at that equation, does everybody notice that? Woohoo, it's quadratic. It's of that form, f of x equals ax squared plus bx plus c. And in making that comparison, does everybody see that since a is -2, this would be opening downward. And because it's opening downward, the vertex would be the maximum value. And so we're looking for the y value of the vertex to be the maximum. Where that occurs is at my axis of symmetry. X equals -b over 2a, which would be the negative of 14 over 2 times -2, which is -14 over -4, which would give me 7/2 or 3.5. And so my maximum area occurs when these edges that I turn up are 3.5. And the area would be the function value at 3.5. Oh, I apologize. Let's go to the written out one. And so I'm going to use my calculator to evaluate this. So I've got 14 times 3.5 minus 2 times 3.5 squared. And so the cross-sectional area will be 24.5 square inches. And it would occur when I turn up 3.5 inches.
God bless you.
Thank you. And so this would be the depth. And this would be the area. And so here we didn't really even graph a parabola, but knowing that the maximum or minimum occurs at the vertex helped us realize, since it's opening downward, that vertex is a max. The x value of the vertex is my axis of symmetry. The y value of the vertex that I get from substituting that in will be that maximum value. So do you see how beyond using this stuff to graph, this stuff has got practical applications? How cool is that? There are a couple other word problems in the homework that work with different situations. I snagged the last one from the assignment to do as an example, because usually the last one is the most difficult. Any questions on anything that we've done today? If not, this is the end of what's involved in this third unit. This is the end of what will be on that test next week. This is the last of the new content. On Tuesday, we'll go over that practice test. Please try to get most of this homework done. I know it's not due Tuesday, but even if you don't do it, please try to at least read over all of this homework before Tuesday, so that if you have questions, we can answer them. All right? Anybody have any questions on what we did today? It doesn't happen often. Would it hurt anybody's feelings if we actually did the unspeakable and ended class a little early today. I have a tendency to run over and not end early because I feel like when I end early, I'm not giving you guys your tuition's worth out of me. But if it's all right with you, shall we call it a day?
I'm okay with it calling it right now. I had pretty much, it was a pretty good day. I learned a lot.
Okay. All right, let me just, Joseph P., I don't think you were here when I took attendance. Let me add you to the class. Anybody else come in after attendance? I don't think so. I think I got everybody else. So have a great long weekend, everybody. If you are of the mindset, happy Easter. If you're not of the mindset, happy beginning of spring. Enjoy that long weekend, and we'll see you all on Tuesday. If you have questions over anything, please send me an email. And I'm sorry I didn't plan on some amazing April Fool's joke for you. Have a good one.
Have a good one.
Okay.
Happy
Bye-bye.
Easter, happy spring,
Happy Easter.
every day.
Happy weekend. Bye-bye.
Have a nice day. Thank
Bye.
you. Bye.
Joshua, Ellie, do either of you have any questions?
No, I'm sorry. I thought I closed out.
Okay, that's all right. I just double check because I don't want to boot anybody out of class if they're waiting for to get a loan. Because I know some people want to ask questions without other folks around. And so